Hi, I'll go over lab 5 of ECE 286, which is regarding AC power delivery. So experiment 1 is capacitance and power factor. So you have a circuit where you have two parallel branches composing of resistors and a single capacitor and one resistor that's in series with the power supply. And you want to measure the power factor. And the way to measure power factor is measuring the current and voltage, and then determining the phase difference between both of those signals. Unfortunately, the 82 or the M2K cannot measure current. So what we're going to do instead is measure the voltage across a resistor that's in series with the power supply, essentially giving us the current. Because if you have the voltage of a resistor, you know the nominal value of the resistance, you then implicitly know the current flowing through that resistance. So that's what we're going to do. Since resistance is not a frequency dependent element, unlike capacitors and inductors. So we have the circuit, and that's what I have built here. Okay, so I have replaced a few of the components. So I believe you need to use two 100 ohms, and you have to use 100 ohm in series with that capacitor and 100 ohms in series with the voltage supply, and then just a 1K load. I replaced those 100 ohms with 1Ks and then that load as 3K. So here's my 100 nanofarad capacitor, the two 1Ks, and then that 3K. So I'm going to open up Scopy. If this wants to work, there we go. Cool. Go and connect to it. Cool. Okay, now I'm going to go to signal generator, and we have to supply a 5-volt source at 3 different frequencies. So I'm going to choose the middle one. So it's going to be my 5K. Perfect 5K amplitude will lead me to a 10-volt peak to peak. Okay, I'm going to go ahead and click run. And then on my oscilloscope, I'm just going to get rid of all this extra junk and go and click single. And now channel 1 is way too big. So I need to decrease that or increase it, and then now go and click single again. Perfect. So now you could see it. So channel 1 pardon me. Okay, cool. I had it right. So what we're doing is we're measuring the voltage and then measuring the voltage across that resistor. So we're measuring this voltage supplied and that the voltage through this resistor. So if you divide this voltage measured of the resistor by its resistance, you get its current. So let's just think of it as current. So the purple waveform is essentially current. Let's say if you divide the amplitude by 1K, because that's what my resistance is. So now if you want to measure the phase difference, you can easily go to cursor. It should be placed, where is it? Do tracking, and then go ahead and measure it at the two peaks. I'm going to increase the size of this. There we go. Okay, so roughly there and there. So the change in time is about 100 microseconds. If you relate that to phase, you have to multiply that change in time by 2 pi and divided by the period, and that will be your phase shift. And if you, I believe, take the cosine of that phase shift, you get the power factor. Don't quote me on that, but I'm pretty sure that's right, though. Pretty sure. And then you evaluate the circuit at 2 other frequencies, and then you still estimate the phase shift at those 2 other frequencies. So for experiment 2, we have a inductor instead of a capacitor. So it's an easy fix over here. Just take this out, and then I will grab my inductor. So here's my inductor. It looks different. Oh, this isn't syncing with my actual camera. There we go. Okay, coolio. And so now I'll just go ahead and connect my inductor right here. Cool. So then if I go on here and then, go ahead and click single, you see how it changed, right? It shifted a bit to the left. So the orange again is our input voltage, and then the purple is still that voltage of the resistor in series that's applied. So essentially our current, and then you can measure that change in voltage. So experiment 2 has 2 additional parts to it, and one is adding a 100 nanofarad capacitor in series with the inductive branch. So right here, we're just going to add another another capacitor in series, and then we'll record the phase shift again. And you want to also adjust the frequency from 100 to 25 hertz, kilohertz, and observe the voltage of the 2 points. But what you could also do is just do a frequency sweep. Your TA might not require this, so just confirm that with your TA. So yeah, when you do add that capacitor in series with that inductive branch, you want to measure it at 4 different frequencies. And so I'll just show you how that 100 nanofarad would affect the circuit. Mind you, the resistors that I use is different, so the change might look different for you. So let me just connect this 100 nanofarad in series. I'm going to click single. You saw the little shift. And then now you also want to do a parallel correction. The one we just did was serial. The parallel one is removing that 100 nanofarad capacitor and placing it in parallel with that 1K load right here and that inductive resistive branch. So it's just going to come right here. So let me rewire my circuit. Oop. Okay, cool. So yeah, if you look at it now, you see how that's in parallel with those inductive resistor branch and that resistor. And then if I measure the data again, you saw how everything kind of changed, right? Yeah. And then now you follow the manual and you measure it at the 4 different frequencies it says, and then you kind of do the frequency sweep again, I believe. Yeah, you're still doing a frequency sweep. Just confirm with HK if you actually need to do the frequency sweep. But yeah, that's essentially how to do lab 5, I believe. Yeah, good luck.